and
Hey,
show you.
Shauna, real quick. My dad said that he sent it to you again.
All right, no worries. I'll check that later
Okay.
because I want you to see something. Now, if
Yeah,
you
yeah.
notice something here, this function 200 plus 80x over 2 plus 0.5x, this thing is basically a linear function. And so what's happening here is that you have a line going on, right? And so what's happening is this goes to infinity, is this is going to approach a finite number. Now let me set up something here because I want to show you that if I'm looking for the limit, there's a limit that this x is going to approach because this term right here, this piece here, the limit of this function at infinity is driven by what this is doing. This 80x over 0.05, right? And so your horizontal asymptote here is going to be given by the ratio of this. So your horizontal asymptote is going to be y equals 80 divided by 0.05. Okay, so if you divide 80 by 0.05, which is not as hard as it looks, okay, this is 80 divided by 500ths, okay? So this, if
Okay.
I was going to do this by hand, this would not be arduous. This is 80 times, keep in mind I have to flip this over, right? So this would be 100 over 5. Are you following me there?
Yeah.
Now 100 over 5 is 20. Would you agree with that?
Yeah.
So 80 times 20 would be your limit, and 80 times 20 would be 8 times 2 is 16. This is 1,600 fish. Now, if I go and I need to expand this out so that you can see this, but if I say, let's scale this to 2,000, let's say, let's go from 0 because negatives don't mean anything to us here. And I'm going to scale this by, let's say, 200 fishes, right? And I'm going to scale my y from 0 to 100 years out. Scale that by 10. Just so we can see a little better what we're dealing with. So if I'm looking at that, then I'm looking at this function here, right? So as this goes to infinity, this is going to be your limit as you go to the function. There's my, you see I have a straight line, essentially. Now, the reason that it looks as straight as it looks is because of my scale. okay? But this is gonna be my maximum. So there are, or I can say the population of fish in the lake reaches a maximum of 1,600. That's what it's approaching, is 80 divided by 0.05, right?
Mm-hmm.
So that's what that corresponds to, all right? Now let's look at the rest of the parts. I'm gonna have to stop sharing. I'm gonna, let me get rid of this and let me do this so I can pull out the, yeah, I scaled this too big. But let me take a screenshot of this part first. So I can't, whoops. So I can screenshot that. Let me go back to your email. And you should have gotten this part in your email, okay?
Okay. Thank you,
I
Shauna.
wrote that out for you. Now let me write out let me find the other piece, the other screenshot that you sent me. It says, is the function n continuous at 8? Justify your answer. Okay. So let's see if we can justify this. All right. Now we know how to do continuity
Mm-hmm.
because we've done continuity a bunch of times. So we're going to show continuity, right? So what we're going to do is we're going to, first of all, we have to do something here. And I'm going to go to the whiteboard for this part of it. So I'm going to go to my whiteboard here. Here's my trusty whiteboard. And this is part B. And it says, is n, or is the function continuous at 8? Okay, well, if I want to show continuity, right, then I have, so what we're going to say in terms of our justification is this: to show that a function is continuous, it must be true, continuous at some value A, it must follow that. And we write the definition. We say, and you're going to remember this because we did a lot of work on this. Remember the limit? So here's our continuity rule, right? The limit as x approaches, in this case, we're going to use t. So the limit as t approaches 8. And I guess this should be, I'm gonna erase this. At some value, it must follow that the limit as t approaches 8 of f of t this is f of t f of 8 is equal to f of 8. Now, I think what I was going to write over here was this. The limit as x approaches 8, a of f of x. This is my continuity definition, okay? Is equal to f of a. So here, I'm just replacing the letters. My x is t, right? My a is 8. So I'm looking to show that this is true, right? So first of all, 1, f of 8 must be defined. And we know from the function itself that f of 8 is defined, right? Because if you look at the bottom function here, the bottom function, f of 8 is defined, we could say that since
Hey, Shauna, can you hear me? It's cutting in and out a little bit.
yeah, I can hear you. Can you hear me?
Okay. Yeah. That's
N
better.
of t is equal to, and this is the third part of the function, right? So you're going to have 200 plus 80t over 2 plus 0.05, 2 plus 0.05 t for t greater than or equal to 8. This expression can be evaluated for when t is equal to 8. And furthermore, this value exists because 8 is in the domain. See, the domain restriction would be 2 plus 0.05 t is equal to 8, right? But it's defined for 8. We can prove that if we plug it in. So we have n of 8, which we're going to need this value anyway, right? N of 8 is equal to 200 plus 80 times 8 over 200, 2 plus 0.05 times 8. Are you with me here? Hannah?
Yes.
So now I'm just going to do some arithmetic. This is equal to, this is 80 times 8 is 640. 640 plus 200 is 840. So this is 840. And then this is 2, this is 0.05 times 8. So this is this is 40, and then it's 0.04. So this is 2 plus, and you can do some arithmetic here. This is 40 hundredths, which is 4/10, right? So this is going to be 0.40 here. So then I can divide this out. This is equal to 840. And you can verify this with a calculator, divided by 2.4. So this is going to be 840 divided by 2.4. So now I can do some, depending on how you want to handle this in your head, might just be easier to add some zeros and divide. I think if I was doing this by hand, I would probably do this, 840, then add 2 zeros to the top, and then divide the bottom. And I added 2 zeros to the top, which means I can divide by 240 down here. And what that allows me to do is cross out the zeros and divide 8,400 by 24, which is a little easier calculation. So whatever this comes out to be, which for the sake of time, I'm going to go ahead and divide that. So this is going to be 840 and 2 plus. So this is going to be
Is it just a really long problem, Shauna?
well, it's not a long problem. It's a lot to do by hand that I'm not interested in. But this problem is, the thing is, if I'm doing the whole thing by hand, then I have to spend all the time showing you the arithmetic. And I'd rather show you the calculus than show you the arithmetic.
Okay.
If that makes sense.
Whatever you think's best.
2 plus, this is going to be 0.05 times 8, right? So this comes out to be 350. Now, I need this number to be, because if I'm going to do this by hand, then I have to go back and do this. So I know that 24 into 84 goes 3 times. That leaves me 120 here. And so that's going to be, it's going to come out 350, but it depends on how good your times tables are, honestly.
Oh, okay, I see.
But this comes out to 350. Now, the reason that I need that, I need this number, is because remember, I need to do this. That's the first condition, right? That f of t exists, right? That f of 8 exists, rather. Now, I need to show that the limit exists on both sides of 8. So I've shown that condition 1 works, okay? Now, condition 2 is that the limit exists. So this is part B continued. Part B continued, right? And I need to show that the limit as x approaches, or t approaches 8 from the left, of n of t. Do you remember doing this? We did a lot of these.
Yeah. A little bit.
In order to show, go back and look at the lecture on continuity if you need to.
Okay. This is just where you plug it in, right? And then
Right. But I have to write out all this as my justification.
oh.
That's
Okay.
why I'm doing all this.
I see what you mean.
Because I have to write it all out.
Right, and
The
that's a
limit
lot.
as t approaches 8 from the left of n of t is going to equal the limit as t approaches 8 from the right of n of t. Remember, there's 3 conditions to continuity?
Right.
Remember all those continuity homework that we
Yeah.
did? That's what I'm doing here. I'm writing out the conditions.
Oh, I see.
So the first condition was that n of t had to be defined, which I showed. Now we have to show that the limits are the same. Now, if I'm approaching n of t, if I'm approaching 8 from the left, then for the limit as t approaches from the left, use the piece of the function defined for values close to but less than 8. So in that case, we're going to have the limit as t approaches 8 from the left of n of t. And which piece of the function am I going to use?
The middle one, right? Wait.
I have to look at it. Yes, the middle one, between 6 and 8. So the
Right.
limit as n approaches t, the limit as t approaches 8 of n of t from the left is going to equal the limit as t approaches 8 t approaches 8 from the left of 25t plus 150. Okay, now I can and since this is a polynomial, it's continuous there, so I can plug this in. So this limit is going to be 25, right? Times 8. 25 times 8 plus 150. Okay? So this should be familiar to you. So the limit as t approaches 8 from the left of n of t is going to equal 8 times 25 is 200 plus 150. That's going to equal 350, right? Now I have to do it from the right. So now I have to do this. I have to say, well, I have to say the limit as t approaches 8 from the right of n of t Now what function am I gonna use for that?
For the right.
Remember here, it has to be through values that are larger than
Okay.
8.
So that would be 200 plus 80t over
Right.
2 plus,
That would be our
yeah,
lovely fraction at the bottom, right?
right.
N of t would equal, this would equal the limit as t approaches 8 from the right t approaches 8 from the right of plus, oops, there it is, of this function, which is my friend, 200 plus, this is going to be 80t over 2 plus 0.05 t, right? Now, again, we can plug in this 8 by direct substitution. So we can say that the limit as t approaches 8 from the right, and I'm going to skip the arithmetic here. I'll plug it in for you, but I'm going to skip the arithmetic. T approaches 8 from the right of n of t is going to be equal to 200 plus 80 times, remember we're plugging in 8 because we're approaching 8 now.
Mm-hmm.
And then we're going to divide it by 2 plus 0.05, right?
Right.
2 plus 0.05. Now, if I did the arithmetic for you on the previous page, and you saw me do it with the calculator, so I can
Right.
say that the limit as t approaches 8 from the right of
Okay.
n of t is also 350, right?
Uh-huh.
Now, so here's my second condition. Since now, if I want to do a similar justification, which I didn't write, but I should, since for the limit as t approaches from the left, use the piece of the function defined for values greater than 8. So here, there's my value. Now, since going back to my box here, hold on, let me, lost my whiteboard annotators. Let me go and erase this. So now I'm going to say that since I lost my train of thought. Give me a second. Need to annotate the whiteboard. Oh, I know what I was going to write. So I was going to say, since the one-sided limits are equal, the limit as t approaches 8 of n of t exists and is equal to 350, right?
Mm-hmm.
It's equal to 350, right?
Yeah.
Now, part C of continuity, we're still proving continuity, right? So
Yeah.
this is part B still, okay, but it's the third continuity condition. So the third continuity condition, which is what shows that it's actually true, is that f, in this case, n of 8 should equal, let me actually put the limit as t approaches 8 of n of t is equal to n of 8. All right? And we showed, now, this first part, this part on the left here, right?
Mm-hmm.
I just spent the last whiteboard showing you that this condition, okay, by the previous work is equal to 350, right?
Mm-hmm.
And this n of 8 by the work in 2 whiteboards ago, okay? By the
Mm-hmm.
work in part 1 of part B is equal to 350 as well, right? So since that's true, we can say that therefore, the conditions to satisfy continuity are met and the function is continuous at t equals 8. Okay?
Mm-hmm.
Because I've shown you that those conditions hold. You follow me?
Yeah.
So if I want to show continuity, I have to show that this holds. That the limit exists and that it's equal to the function value.
Right. Yeah.
So part C is going to be similar, but then they extend it.
Okay.
The part C of your question says, the function n is continuous at 6. Is there a time t between 0 and 6 at which n of t is equal to 250? Justify your answer. Now here, we could do this a couple of different ways, but this is our old friend, the IVT. Okay? The intermediate
Got it.
value theorem, because we have to go back. We have to go back and we're doing it from 0 to 6, okay? Not 0 to 8, all right? So what we have to do is we have to show that we can show something that works. So for part C of this, we have to do, now there's things we can do. There's different things that we can do with this, all right? But let's assume that we are going to, let's think about the interval from 0 to 6, okay? So just so we remember this, we're on the interval, because this is important, it's closed interval, and this will give us a chance to go over the intermediate value theorem again, because that was we did a lot on that, and you got rather good at that. But it's worth revisiting it.
Okay,
Here's
cool.
my function 0 to 6, right?
Uh-huh.
Now, there's my function 0 to 6, right? There's my interval, and I want to know, is there a value for which, is there a value t for which n of t is 250, okay? Well, for that, we can use the intermediate value theorem, okay? So we're gonna use the intermediate value theorem, okay? So what the intermediate value theorem says is the condition here, the condition for use is that the function must be continuous on the interval, okay? Well, they told you that it was continuous, right? If you go back to the problem, go back to part C, it says the function n is continuous at 6. The function is continuous at 6. Is there a time for which that's on the interval from 0 to 6? So now looking at the equation from 0 to 6, right? It's continuous at 6. Is there a time between 0 and 6 for which this is continuous? We know that this function is continuous between 6 and 8, right?
Right.
And we know the function is continuous at 8, okay? Now there is a discontinuity in here at the function greater, when it's greater than 8, but we don't care about that, okay? So here we want to know between 0 and 6 when t is equal to 250. Well, what we can say is that we know that here, okay, so we can say that they told us, another thing they told us is that n of 0, this is going to be important to us, n of 0 was 80. I don't know if you remember that, but they told us that back in the, okay? N of 0 is 80, okay? And we know that, now we don't know what n of 6 is, but we can find out what n of 6 is, right? So let's find n of 6. N of 6 means that we have to use n of 6 equals question mark, okay? So we have to use the part of the function that's defined for 6, and that is going to be f of t, right? I'm sorry, it's gonna be, no, I lied. It's gonna be, I think it's gonna be the middle one. Let me check it again. Because I think they told us, if I remember, oh, wrong share. Let's see. Is it this one? No, I need the problem itself. Hold on, let me go back. Because I have two sets of this open. Let me go back to my email. Let me go back to my email and grab, I need to look for the function because I didn't write down the condition properly. So let me, here's the function itself. And let me see if it will share the screen. There it is. Can you see it on the screen? Okay, so it's equal to 6, and it's 25t plus 150, right? You see that? Anna?
Yeah. Yes. Yes,
So
Shauna.
at 6, we're going to plug it into this middle one and figure out what's going on here, right?
Okay.
So remember, it didn't ask us what the value was. It just said, is there one? Right? Just said, is there one? So here, we're looking at this and we're saying, all right, well, we know that it's continuous at the end point. And we know that it's continuous because they told us that it is continuous. We know that we have some continuity problems at 8, but otherwise, we're told that it's continuous, and this middle part is a polynomial, which is continuous, right? So here's what we're going to do. This is going to be, we're going to plug 6 into this middle piece. So we're going to evaluate this. We're going to use, to evaluate n of 6, use the condition or use the definition of the function for which 6 is less than or equal to t. Oh no, 6 is less than t, less than or equal to 8, right? So now we're going to plug 6 into here. So we're gonna have n of 6. I'm gonna put it down here. N of 6 is equal to, we're gonna plug it in, it's gonna be 250, no, 25, sorry. 25 times 6 plus 150. Okay?
Mm-hmm.
Well, if you multiply that out, again, the arithmetic is not that strenuous. 6 times 25 is 150, right? So this becomes 150 plus 150, which is 300. Are you with
Mm-hmm.
me there?
Yes.
Okay. Now, if you remember, do you remember what the intermediate value theorem says?
That your f of x has to be like the same as your limit, right?
That's, okay, no, that's the continuity definition.
Okay.
Okay, you're mixing them up right now.
Uh-oh.
The intermediate value theorem is the one that says that if I have, so it says, is there a value on the interval from 0 to 6 for which n of t is 250? So the intermediate value theorem here, remember, we know some things about this function. We know that we're on the interval from 0 to 6, right? We know that we're on the interval from 0 to 6. We know that n of 0. So what we calculated was this. We know that the interval from 0 to 6 is the interval, and that n of t is continuous at the endpoints, right? Because that's given. We know that n of 0 is 80, because they gave that to me, right? We also know by calculation that n of 6, because we just figured it out, is 300. Would you agree with me so far? Okay.
Okay.
Are you sure? You don't sound very convinced to me.
A little. Can you explain it one more time?
Sure. So
Okay.
if you remember, maybe let me get you this, because I think you're mixing up continuity with the intermediate value theorem. So let me do this.
A little bit.
Let me stop. Continuity is a condition of the IVT.
Okay. Okay.
But it's not the same thing as the IVT. So
Okay, got it.
let me come back to this and remind you here, section 1.8. Where are my PowerPoints for that? This is the one that I showed you PowerPoints of.
Okay.
So I know I showed you PowerPoints of a couple, but I think if I show you again, it will click back. It's a lot of rules and calculations, and so I'm not surprised. I think more than anything, you're probably mixing up the names of
Okay.
of the, but this is the one where, okay, let me bring it up here. And let me remind you of this. So here, this is a lot of rigmarole right here, okay? So here's my continuity, right? So when we were studying continuity, we talked about this. This thing, you remember this, right?
Yeah.
Continuity test. This is part B of your problem.
Okay.
This is the 3 conditions, okay? Minus the picture. This is the 3 condition that we did. And when I was testing it, I had to go and test these conditions, right? So that was continuity. And that's what you saw me do just now in part B, all right?
Okay.
Now, then we had the types of discontinuities. We talked about that. But then we had this thing at the end. Let me scroll down. We had this thing. This is what we're using right now. A function is continuous on a closed interval from A to B. In our case, that's 0 to 6. Takes on every value between f of 0 and f of 6. Okay? So what we've shown is that it's continuous at the endpoints. They were given that it was continuous at the endpoint. And we know that f of t is continuous there because it was given to you, okay?
Right.
The middle piece from 6 to 8 is a polynomial, so it's continuous on this interval, okay? So if it's continuous, then there must, now, if you have, now here's the thing. We know in your case, we know this because we're given it. We know that f of 0, or n of 0, I should say, n of 0 is 80, because they told us, okay? And then we calculated n of 6, okay? And that was 300, right?
Yes.
Now, what we want to know is there a value between t equals 0 and t equals 6 for which n of t is 250. That's what we're trying to show, okay?
Okay.
That's what we want to do. Now, if we steal, I'm going to steal this graph for a minute, okay?
Okay.
This is not my function, okay? But I'm going to steal this for the sake of example. So here, this is, now, this is A and B, so you have to kind of think about this. This is our 0, okay? This is 0. This is 6, okay? Now, f of 0 here, this is the point, this point right here, where you see these dotted lines, this point would be 0, 80, okay? That's, so f of 0 would be 80, right? Now, here, this is the point 6 and 300, okay? Now, what she's asking is, is there a point somewhere between 0 and 6, some point C, right? Is there a point C where we have six and 250? I'm sorry, not 6, but C, some point C, and 250.
Mm-hmm.
Okay, well, guess what? If it's continuous between 0 and 6, isn't it? And my Y values go from 80 to 300, yeah?
Yeah.
Then there has to be a point in here where it went to 250, doesn't it?
Right.
So that's what I'm justifying right now.
Got it. Okay.
Does that make sense?
Yes.
So I'm gonna screenshot this because I stole Professor Nick Dell's drawing. Thank you, Professor. We appreciate it. I'm gonna save that, but I'm also going to clear this out. Now, I'm gonna come back to my whiteboard here. And I'm gonna say that we know that on the interval from 0 to 6, we know that we have 80, we have 300 here, right?
Mm-hmm.
And
Yes.
so we can say that since the function is continuous on 0, 6, right?
Mm-hmm.
Since the function is continuous on 0, 6, and how do we know that? We know that because it's a continuous function because we have a polynomial for the second part, right? And polynomials are everywhere continuous.
Right.
So the function is continuous on 0, 6. And since n of 0 is less than 300, or than 250, right? And n of 6 is greater than 300. That is n of 0. Actually, 250 is less than C. No, 250 is less, I'm sorry, 80 is less than 250.
Mm-hmm.
80 is less than 250, is less than 300. And therefore, there exists a value C. There exists a value C in the interval from 0 less than C less than 6, for which n of c
Mm-hmm.
is, I'm not sure if I wrote this out exactly right,
Okay.
but that's the intermediate value theorem, okay? I'm not
Okay.
sure if I got all the notation exact, but that's the notion of that, okay?
Dang. Okay. It's a lot.
Well, I might have written more than she actually wanted, but I'm trying
Okay.
to make sure that you
Do you want me to
have,
look at the rubric?
have everything that you knew,
Yeah, Shauna, did you want me to look at the rubric?
if you'd like.
There's a key. There's a key on this one. She
Oh,
just keys
she
for
gave you the key? We went through all
yeah.
that for no reason? No,
Well, not no reason. I
I'm
feel like I
kidding.
learned
I'm
something.
kidding. No, I wanted you to understand it. I hope I didn't overkill you too much. But go
Well, I mean,
ahead.
it's a little bit of a lot, you know. But
No, it's a lot of material. I grant you that. Go ahead and share your screen.
all right, let me see how to do that. Also, give me 1 second.
I have about 20 minutes I can give you. Okay.
Okay.
So we have some
Thank you,
time.
Shauna, by the way.
No worries.
Let's see. Is
No
this
worries.
the
I
only
hope I didn't kill you. I don't want to kill you off and make you not want to come back. I
No, it's perfect. Because I've been freaking out about the our FRQ tomorrow. I'm like, I don't even know what she could test us on at this point. Hello?
I'm seeing your Google Classroom screen.
Yeah, I'm getting it up. Sorry.
No worries. I just thought it was attached to your homework. That's all.
Well, it's on my homework. Like my homework
Oh, I see.
is on Google Classroom, but I can't go
Got
through my classroom tab because I'm making an assignment for yearbook.
I gotcha.
So I don't want to.
And resume here. So now what I'm going to say to you is this. When you were looking at the limit continuity conditions, there's three parts. Okay.
Okay.
So if I come up here, let me annotate on the screen. Here's what this says. It says that this is my definition right here. This is what I have to show. The limit as t approaches 8 of n of t has to equal n of 8. Okay, I have to show that. Now
Yes.
that implies that n of 8 exists. I
Okay.
did this first. All she did was write the result. Okay, n of
Okay.
8 is 350. What did she do? She plugged that in to this fraction. She plugged 8
Right.
into it. Okay,
Okay. Uh-huh.
so the function, this says the function exists at 8. Okay, it
Got
exists.
it.
The second condition, what I used as the second condition, the order that you prove these in doesn't matter too much, except you have to prove all three. Okay,
Uh-huh.
so the second condition, this is what I did for number 2, is that the limit from the left of 8 and the limit from the right of 8 have to match each other.
Right. Okay.
Okay, so here she wrote the part of the function that she was putting it into.
Uh-huh.
On the left, you have to choose values that are less than 8. So she chose this middle condition. You plug 8 into it, you get 350.
Got it.
If you plug it into the right, you get 350.
Got
Okay.
it. Okay.
Now, the third condition, which she didn't specifically write, is that these have to be equal to each other.
Right. Okay, so that's where that's where it comes to be like limit as t approaches 8 from the left or from the left side equals limit t approaches 8 from the right side,
Right,
right?
she didn't write this in, but
Okay.
see, since these two answers, then this is where this makes it look like I didn't write enough. I mean, like she didn't write enough. These two answers here,
Uh-huh.
because these two answers match, the limit exists.
Got it. Okay.
So here she's showing that the limit exists.
Got it. And then if the limit exists,
Now, here she showed that the function is defined, right? Now, if the function is continuous, then the answer that you get for the limit, which is what? What
okay,
answer
wait.
did she get for the limit?
For the limit, she got 350.
Uh-huh. And what answer did she get when she evaluated the function?
She got 350.
If all three of those answers match,
Then it's continuous.
then it's continuous, which is what she's saying here.
Right. Okay, because if like, okay, what is it called again when it's n of 8, like f of 8, or like if n of
If
8?
the function evaluated at 8,
Okay, the function evaluated at 8, because if the function evaluated at like 8 was like another number, that means that there was that would be a discontinuity, right?
yes,
Okay. Okay.
yes. So I can either have a discontinuity because the limit doesn't exist. In other words, one of these doesn't match each other. Or
Yeah.
because this is undefined in the first place, the function is undefined. Or the limit doesn't match the function value. So
Okay.
there's at least 3 ways for me to fail. Okay.
Okay.
But so let me repeat this one more time. The limit exists because the left-sided limit and the right-sided limit are the same. The limit exists, okay?
Yeah.
The function is defined because when we plugged in whatever number, could have been 8, could have been 10, whatever she chose 8.
Got it.
When I plugged 8 into it, the function was defined there.
Got it. Okay.
Okay? That doesn't necessarily automatically guarantee that my function is continuous unless those 3 answers match.
Okay, I get it.
Since
Okay.
those 3 answers match each other, n of t is continuous at 8.
Got it. Okay.
Yeah?
Yeah.
So there's 3. She didn't write the third one. She kind of snuck it down here. I mean, it's there, but I would have
Yeah.
added an extra step. But this is her third condition here.
So to evaluate the function, does that just come with doing it from both sides? Or where does that come from?
Can
Does that make
you
sense?
help me understand what you mean? Because you broke up.
Like,
Hello?
sorry, I meant like, okay, oops. Shauna,
Yeah, I'm here.
hold on, my internet's freaking out. Can you hear me now?
I can hear you. I'm going to go ahead.
Okay. So how it says like how do you get that?
You broke up, Hannah. Can you put your question in the chat?
Probably makes no sense.
Can you put your
Oh,
question in
okay,
the
hold on,
chat?
let me. Yeah.
Because you're breaking up and I can't
Okay.
I'm gonna drop it in here. And I'm gonna close a few things here. Can you hear me?
Yeah, I can hear you.
Okay. So what were you saying?
It's like it's kind of weird. It's kind of like I don't know. I feel like it's not like a. You've probably gone over it. I just probably lost it. But I meant like, you know how you have like f of 8 equals 350?
Uh-huh.
How do you how do how do you know you have that makes sense?
How do
Like
you, how did I get 350 from that, you mean?
kind of, yeah. I mean, I get that you get 350 from the other two by
Okay.
inputting 8 into like those two
So,
equations.
so if you look at the function, look at the function that's given.
Okay.
Look at the function that's given to you.
Okay.
Find the condition where it says what, where t is 8. Find that condition. What is it?
Okay. Where t is 8?
T has to equal 8. Which condition
Okay.
is that?
That's the third one. That's 200 plus
All right.
80t. Okay.
Okay. So now if you look at the whiteboard that I'm sharing here, right?
Uh-huh.
You're putting in 8 everywhere t occurs.
Okay.
So if your condition here was, so here's my function, right?
Mm-hmm.
Suppose that I simplify the question, and suppose I say find f of 8. Okay.
Okay.
If my f function is this 200 plus 80t over 2 plus 0.05 t, right?
Okay. Yeah, yeah.
So what am I going to do?
Plug in or input 8.
Yeah.
Okay.
So what I'm going to get
It's
is I'm
350
going to get,
eventually.
right, because I'm going to get this 200
Okay.
plus 80 times 8 over 2 plus 0.05 times 8. You with me?
Uh-huh.
Now it's just a matter of doing the arithmetic.
Okay.
Are you having a problem doing the arithmetic by hand? Is that what it is?
No, I mean I can do that by hand. Eventually, I mean I can do that by hand. That's not a problem. I think I'm just getting nervous
Was
because I,
that your
you know,
question? Was that your question or no?
yeah, yeah, yeah. That was good, Shauna. Yeah. That's what I needed.
So that's what I usually do for the first part of continuity, but it doesn't matter
Okay.
if you do the limit first. You have to do both, all three parts, and then show that the limit is equal to the function value to show that it's continuous.
Okay.
Okay?
Yeah.
Does that
Okay.
help?
Yeah. Thank you, Shauna.
Did I manage to unconfuse you enough
Yeah. Yeah.
to keep my day job?
Oh my goodness. I could never fire you, Shauna. You're the best. I could never.
No, but sometimes it, some lessons go better than others. I get that.
I think you're just passionate, Shauna. You're just passionate.
I know, I just want to explain all the details, especially when it
Yeah.
says justify.
Yeah.
So,
Justify me. No, I get what you
okay.
mean. I know,
Well,
especially because those words on those certain type of questions, they mean different things.
yeah, exactly.
Because
Well,
when I was taking bio, if they said justify, they wanted like 8 sentences. They wanted a lot.
Well, let me tell you, Hannah, if you go through this problem again and you're writing it out, I'll be up tonight. I'll be up with my other student probably.
Okay.
So if you have something, text me and I'll text you back. But I think for the most part she wrote it out, but she didn't really tell you why she made the selections that she made. So I tried to, I'm gonna give you the I'm gonna give you the screenshots, but I'm gonna call my student
Yeah, yeah.
and I'm gonna send
Go
you the
for it.
screenshots and I'm gonna render the video. The video will probably render by tomorrow morning.
Okay, sweet.
But the screenshots, give me maybe 15 minutes and I can send them to you.
Okay, perfect. Thank you,
Okay?
Shauna. Yes,
Thanks,
thank you.
sweetheart. I'll talk to you
All
later.
right.
We'll talk tomorrow night. Okay? I have two meetings, one from 3 to
Okay.
5 and one from 5
Good
to
night,
6.
Shauna.
So I'll talk to you later tomorrow. Okay? Bye.
Okay, sounds good. Good night, Shauna. Thank you.
Good night. You're welcome.